Hi, welcome to week 2 of Algebra 2 Accelerated Distance Learning Style. So I'm going to try and keep it the same week to week, more or less. This week, you probably want to take the time to do the worksheet because I'm basing the formative quiz and the summative test on Schoology off of the worksheet more. So if you do the worksheet, then some of those questions or very similar questions are going to be on the Schoology formative. And so it'll save you some time and make it so everything kind of overlaps rather than just being a bunch of extra. So that's my goal there. Let's get started. So our topic today is probability notation, which we learned about last week. And we'll review it this week too. So that's nice. And then something new is a Venn diagram. And so the goal is you can find a probability given a Venn diagram using probability notation. So we're bringing this idea of a Venn diagram into math because you've probably seen Venn diagrams in your English class or your social studies class. So maybe your English teacher gave you a Venn diagram so that you could compare and contrast some characters in a story. So what's the similarity between this character and this character goes in the middle where they overlap, but something that's just about this character would be over here, and something that's just about this character would be over here, right? Not in the middle part. Or in history, you might have used a Venn diagram to talk about, oh, there's my dang Bluetooth turning off again. Happens every time. And like we would talk about in history, for example, like if you had World War I and World War II, and then you would say what's similar goes in the middle, but what's different stays in the outer rings. So kind of a fun thing to do, and I really like doing this, and this is one of my favorite things to do all year, is to go over some funny Venn diagrams. They're kind of like memes, and see if they help us understand. Plus, it's kind of fun, and it might help you remember that you've seen it before. So here is one kind of funny Venn diagram, and it's about the school bathroom paradox. Now, I kind of like this one right now because we're not in school, so something teachers have memes about is how like it's kind of nice that we can go pee whenever we want because we're not teaching in a classroom, so that's kind of nice. But so school bathroom paradox, and it has toilet paper, which kind of a sore subject in our world right now. If it has toilet paper, then it's not going to close and it's going to smell really bad. If it doesn't smell horrible, then it's not going to close and it's not going to have any toilet paper. If it has a working latch, then it's going to smell really bad and then there's no toilet paper. And if you get all three, right, this middle part is where they all overlap, then somebody already got to it before you. So it's kind of a funny way to look at it. Let's look at a couple more here. I'm going to move my big old head to the other side so we can go to the next one. Okay, so this one's about social media and I need your help. So if you want to take like a screenshot of this and change it to be something that makes more sense to you, I would love to see what you guys come up with. Also, TikTok is a new social media thing that came about since last year, so I don't know where it would fit in this. But the idea is narcissism, that's being obsessed with yourself, right? Thinking like you're the best person in the world. Stalking, so stalking someone. And then ADHD, I know ADHD is not a joke, it's a real condition, but more like attention, having a short span of attention, which we all do this day and age, right? We're all social media people. So trying to name the social media platforms that would be best suited to these different personality traits. So if you have a short attention span and you're obsessed with yourself, then Snapchat. What do you guys think? Stalking people and you're obsessed with yourself, that would be Facebook. Stalking people and you have a short attention span would be Twitter, maybe. And then Instagram is where they all overlap. So tell me what you think about this one. Feel free to email me a new Venn diagram meme. Okay, this one's the cutest one. It is a narwhal and a unicorn. And a narwhal is a whale that has a big old horn. And so that horn would stick out right there. And then the unicorn is a horse with a horn, right? And so the thing that would bring these two creatures together would be their horn. I hate to break it to you, though, but a narwhal is a real whale, whereas a unicorn is not a real type of horse. Sorry if I burst your bubble, but unicorns are not real. All right, this one takes a little explanation, but I think it's really funny. I think I almost put it in here just like as a personal reminder to like that I get to laugh about this one. Okay, so George Washington, that's this one over here. I'll move this again. George Washington is the first president of the United States. Sir Mix-a-Lot is a rapper from the 90s. He's actually from Seattle. Hometown hero, my hometown hero. And so George Washington, there's this myth, and I realized this a couple of years. Some people don't know this myth because it's a myth. It's kind of silly. But when George Washington was a little kid, supposedly he went out into his orchard and he chopped down a cherry tree for no reason. And when his mom or dad or whoever asked him, like, why did you chop down that cherry tree? He said it was because he cannot tell a lie. So he purposely went out and did something bad because he wanted to say that he would be truthful about having done something bad. It's kind of weird. It's like you like steal money just so you can get caught so that you could say you did it because you're that good of a person that you would do it. Anyway. And then Sir Mix-a-Lot, he's the person who was sampled in Nicki Minaj. Nicki Minaj. This is how bad I am, guys. I'm not hip. But the like Anaconda song, and it goes, the original song goes like, I like big butts and I cannot lie. And it was very popular in the 90s. If you have a second, you should really go on YouTube and look up the original music video for that. It is so funny and so 90s. And like in the background, behind all the dancers and stuff, there's just a giant fake butt in the background. It's very funny. Anyway, so both people cannot lie. That is what they have in common. It's kind of funny too because George Washington is like this old dead white guy and Sir Mix-a-Lot is oldish but still alive. And anyway, okay. And then I think we have one more or two more. So here's possibilities in college, and I think this could be applied to any time in life, trust me. Homework could be replaced with work, any kind of work. So just the big idea here is that you're never going to be able to have a good social life, get all your work done, and get enough sleep. There's just not enough time in a day. This one, I think it's kind of cute. It's about Yoda. So Yoda is from Star Wars, right? So he's small. He has poor grammar because he, it's like this sentence Venn diagram Venn of Yoda. It is. He always says things backwards. And then he's green. And you can kind of take a look. Gary Coleman is an actor. So you can look up who that is too. Okay. I really like this one. It's about DJs, bank robbers, and preachers. And so like bank robbers are like, put your hands up, put the money in the bag. And then DJs are like, put your hands up, put your hands up, put your hands up. And then preachers are like, put your hands to the sky. So I think that's kind of funny. Also kind of funny, although not true about all preachers. They ask for donations, they take money, and then everybody on the floor. So bank robbers are saying like, get on the floor, like face down, and DJs are saying like, get on the dance floor, let's go, let's dance. So anyway, I like that one a lot. This one's kind of funny. I'll let you read it. I think this one's especially true about Minnesota sports fans. short-lived happiness, prolonged suffering, sudden rage. It's funny. Okay, so please, if you have time or you think it would be fun, try to find me some new Venn diagram jokes, because some of these are getting stale. That social media one is really old. I keep trying to change it. It's, not the best one. Okay, so let's get to some math now. So what we're gonna do is we are going to talk, well, what is a Venn diagram? So a Venn diagram is a logic diagram. It's invented by John Venn. That's why it's Venn. And a while ago. And it illustrates simple logical relationships. So it's kind of a big deal. It's like you can draw a picture of something that's hard to explain with words. Very, very, very useful. So let's do the most simple probability. Now we know that this probability of A, right? We learned that last week. All we'd have to do is just look for, and this is a strategy I use, I'd like you to use it too, where you highlight what you're going to highlight in the same color in the question and in the picture. So if I said, what is the probability of A? You would look for everything that's in A. Now, let's add to this a little bit. Let's make it interesting. Let's do 7, 3, 5, and 8 out here, okay? So what is the probability of A? The probability of A, and this is something that the joke Venn diagrams don't take into consideration. Like, you know, they had like Sir Mix-a-Lot and George Washington. What if you're neither of those people, right? Where is that? That's outside of the two things. So this is saying there's 8 things that are not in A and not in B. Kind of cool. And so 7 and 3 and 5 and 8, what does that add up to? Well, 7 and 3 is 10. 5 and 8 is 13. So that would be 23. And so when you find the denominator, you find the total, I oftentimes will put it like on the outside like this, but that's not the same as this number. Those are two separate numbers. All right, so what is the numerator here? It is 7 and 3, which is 10, okay? So it's 10 over 23, and then if you did that on your calculator and you turned it into a percent and you rounded correctly, I always want you to round it to the 100th place. There we go. Okay, so we're just going to look at A. It would be the same thing if it was B, but it would be the 3 and the 5, right? Okay, so converse of A, which means not A, right? Or I might say A prime is another way you might hear it. That would be everything that's not A, okay? So that's everything in the square that is not inside of the A. And I don't know, I think this, you know, the probability that we did last week was pretty, oh no, what happened to my screen? Is it not working? Let's see if I can get it back up here. Hold on one second. Oh, cool. Okay. We did it. So yeah, one of the things we did last week was we were looking at like a spinner and marbles in a bag and rolling dice. This might be easier for some people to visualize what the probability is, maybe a little harder for other people. Okay, so if we have the same numbers here, that means there are 7 items inside of A, 3 items inside of A and B. Oh, and my iPad is lagging a little bit, so maybe I should wait a little bit for it to catch up. There we go. 5 items that are just in B, and then 8 items that are outside of A and B. They're not in A and they're not in B. So we know that the denominator is still 23 because it's the same picture, but everything that's not in A is everything that's shaded. So it would be 5 and 8, which is 13. All right, go to my calculator. 13 divided by 23 times 100. Let's move this over a little bit. That would be 56.52%. All right. Let's keep going here. Union. All right. Remember, union is when we add. We are adding to find the union. So I want us to use this strategy of highlighting where we say, okay, I'm going to do my A in red. Boom, 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 boom. And I'm going to do my B in, let's say, in green. So shade all of my green or my B green here. And let's keep the same values as we're doing these examples. Total of 23. And so union means it could be A, it could be B, it could be both, right? And so it's all of the stuff that is shaded. So it's all shade. Doesn't matter if it's overlapping. It doesn't matter if it's just a single shade. It's everything that's shaded. So we're going to do 7, 3, and 5 added together. So that would be 15 out of 23. Another way to think about it is it's everything except for the 8, right? So I could have just done 23 minus 8. Instead of having to add 3 things together, I can instead just subtract 1 thing. So this is 65.22% right there. Okay, let's keep going here. Of course, you knew this was coming. It's the intersection next. So intersection means both, right? It has to be A and B at the same time. It can't be just B and it can't be just A. It has to be both of them at the same time. So again, let's use our strategy here. Shade the B one color. Shade the A, the other color. All right, and so since it has to be where it's both, it is only the double shaded part. So it's only the 3. And so we get 3 out of 23. Usually the intersection is smaller than the union because it's more specific. 13.04% is the answer to that one. Okay, one more of these definitions, and I'm going to do 3 examples, and then you're going to pause the video and you're going to do 6 examples to make sure you understand. Some of these examples are kind of tricky, but you got it. So pay attention. Make sure you're understanding what I'm saying as I do it. You're welcome to pause and go back and re-listen to what I'm saying whenever you would like. Okay, one more definition. So this is conditional probability. This is the one that trips people up. So let's think about it. Remember, this means it is known. So it's like I'm giving you that we know it's in B. So another word you're going to see is given. It is given, it is known, we already know, it is certain, something like that. And so still, we're going to keep with this strategy. There's our buddy A right there. And then there's our buddy B right there. And then we need to take a look at this pretty carefully. 7, 3, 5, 8. So when it says it is given B, that means in my head, I go, okay, everything but B is dead to me. I never want to see them again. I never want to talk to them again. Get out of my life. Everything but B is trash. So I'm going to go, get away from me, 7. Get away from me, 8. All I care about is B now. It's like when you first fall in love, all you can think about is that person. All you care about is B. So what does that do? It changes your denominator. Since your whole world is B, you only have 8 things. Okay, so now looking at the first part of our question, it says, well, if B is all we know, then what's the probability that it's A? Well, inside of our world that is now much smaller, the only thing that's in A is this 3. And so we're going to do 3 out of 8. All right, let's turn it into a percent. 3 divided by 8 is 0.375. I should have known that. So that is 37.5%. Okay, so I'm going to go and do some examples. I'm going to do 3 examples here. Now, these examples get tricky, but they're kind of fun. You know, it's fun because you get to use different colors and I don't know, if you're the kind of person that gets excited about getting to draw little pictures and make them cool and pretty and clear, then you're going to like these. Okay, so the first thing that we got here, and we're going to use the same strategy. So I'll highlight the first thing first. So highlight A in this picture. And then B prime is the second one. So B prime is everything that's not in B. So like I said, this one's a little more complicated because it's not just A and B. We're combining primes and unions and all kinds of stuff. So now you'll notice that these are all the same all the way down. And I think it's true for the other ones as well. So I'm going to cheat here. I'm going to copy this. And then I'm going to paste it here. And then I'm going to paste it here. Oh, and before I did that, I should have written in the stuff. So 7, 3, 5, 8. 7, 3, 5, 8. 7, 3, 5, 8. Okay, so cheated a little bit, but that's okay. Move my head around a little bit here. Okay, so now we need to indicate where is our final answer. And so in order to show the specific spot that's our answer, I'm going to use another color, and I'll use orange just because it's bright, easy to see. The probability of A union B prime. So that's everything that's shaded, right? And so if I'm looking at this picture, if you were to turn in a question to me that just looked like this, I wouldn't know if you were saying, oh, it's the double shaded or it's everything I have shaded. So I need you to be very specific when you are showing your answer about where is your answer. So everything that's shaded, that's everything but this part. And then that's all of this. And then how I show my official answer, if I'm shading, would be to shade everything there. Now that's doing a lot, right? It's kind of confusing. So if you don't want to do that part, that's okay. You can just go straight to finding the probability. So our question is, what is the probability of A union B prime? Well, that's everything that's shaded. So that's 7, 3, and 8. So 7, 3, and 8 added together is 18. And we still have the same total out of 23. Right? So instead of shading, you could have just looked at the picture and been like 7, 3, and 8, 18. All right, 18 divided by 23 is 78.26%. All right, so let's take a look at the second example here. And let's go back. It says intersection, right? So in your head, you're thinking just the double shaded, just the intersection, right? Just the overlap is another way to say that. So overlap is only, oops, got switched to my orange, is only this part. This is the only part that is overlapping. So it's not conditional, so we still have 23 as our total, and 7 out of 23. I feel like I already did this one, but let's do it again. We got 30.43% there. All right. Last one for me, and then you pause and you try 6 questions. Okay, fruit flies for some reason here. Okay, so this is 735, going back to here. So this is where we bring in conditional, all right? So this is where we get to cut people out of our life. We're like, if you're not B prime, get out of here. I don't want to see your face in this town anymore. Yeah. Okay, so only B prime. B prime is the only thing we care about. The green stuff, good. Anything else, bad. So that means this 3, take a hike. This 5, start walking. So what is our new total? Our whole world just got so much smaller. What's 7 plus 8? 15. So our new total is 15. That's B prime. And then within that, we want to know, right, how much is A? How much of that new world is A? And so A is only the part that is red. So that's this 7. So it'd be 7 out of 15. Okay, so let's do it. 7 divided by 15. Ooh, this one's a good one. 46.67. You might have noticed in the probability things that we were doing before or last week, I put 66.6666 in a lot because a lot of people do not round that correctly. They don't do 0.67. So this is another example. Make sure you're doing 0.67. All right, I am going to pause this, and you guys need to pause it as well. And let's see here. It should pause. How do I pause? Pause. Hello. Hopefully that went well for you. Here are your answers, and I'll just go over a couple little tricky points in each one, just so you know. If you feel like you just want to truck on through, then please keep going. Skip over this next little bit, but I'm going to go over some of these little trickier parts. So for number 4, you can see that it's 11 out of 23. And the reason why it's 11 out of 23 is because it's the all of the shaded parts. So basically, it could be everything that's shaded. Union means all shaded. Doesn't matter if it's double shaded or just single shaded. And so it's basically everything but this 7, right? The 7's the only thing that's not shaded. So instead of doing 3 plus 5 plus 8, you could just do 23 minus 7 because you know the total is 23. Subtract 7, easier than adding 3 things. Pro tip. All right, next one, we got a answer of 5 out of 23. That's because this is the intersection. It's where 2 things come together, right? Just like 2 streets, Minnehaha, White Bear, the intersection is where my arms are crossing. And so the intersection of this is where the shading is doubled. So that would be 5. That's the only double shading. For number 6, our condition, right? Looking at our condition, it's B. Right? Condition is B. I know it's B. B is the only thing I care about. What? A? No. I don't even care. What? Is there something other than B? No. Nothing in my entire life other than B. So I crossed out everything that's not B, and I'm just looking at the 3 and the 5. Okay? That's my total world. So that's why that is my denominator here. All right. And so then looking at that, the question is, now what's the probability that it's not A? Right? Well, this is inside of A, so that's out. We don't care. 3 is not part of the situation. It's part of our world, but it's not what we want to know the probability of. That's why it's 5. It's shaded with the red. Okay, so it's a double shaded area. You can think about it that way. All right. The next one's pretty much the same deal, a little more complicated because it's not A and not B going through these motions, so it's kind of crazy. But again, you can see here the only thing that's not shaded, and since we're finding the union, it's everything that is shaded. So it doesn't matter if it's double or single shaded. So it's everything but the 3. So you could just subtract the 3 if you wanted to get 20 out of 23. This next one has to be double shaded, so that's why it's the 8. It can't be the 5 or the 7. And then the last one, again, our condition is B prime, right? So I crossed out everything that's not shaded in green, and that would be the 3 and the 5. Ignore B. We only want B prime. So now our whole world is 15, and we want to know what is the probability of it being not A, right? The 7 is in A, the 8 is not A. So yeah, that one's tricky. I mean, these are probably more difficult than the ones that I'm going to put on your formative or your summative, but it's good to practice these harder ones so then when you get to the actual questions that you have to answer, it's not going to be as difficult. Okay, so let's keep going here. We're going to take what we learned about Venn diagram probabilities and we're going to apply them to word problems. And, they're not real life, but they're closer to real life than just a bunch of random numbers that I chose with pictures, right? They have applications that are realistic. And these are IB questions, IB style questions. So these are potentially questions that could pop up on an IB test if you're taking an IB test, in a couple of years, once you do pre-calc and then calc. Or even math studies, yeah. Okay, so we'll read through. Let me get my big old head out of the way here. There we go. Let's read through the question, and I'll kind of tell you some strategies to help you along the way. At any point, you want to pause, try it on your own, and then just check your answers and see if you need to listen to me talk to you. Feel free. I encourage you very, very strongly to try these on your own because that's how you develop strategies that work best for you. Okay, but I'm going to push on ahead here. All right, so this first question, in a class of 30 students, so I'm going to stop you right there. 30 students, that's how many total students there are. So that's why my little strategy of having my denominator on the outside of the picture is helpful because it saves the information. I don't have to go back and look for it. It says 19 study physics and 17 study chemistry. So to keep things clear, I'm going to use P and C instead of A and B. And when they say 19 study physics, they mean 19 that just are in physics and that overlap with chemistry, right? So those two things are going to add up to 19. So where can I store this information in my picture so that I'm not confused? What I'm going to do is I'm going to put a little 19 in parentheses next to the P. Now that indicates to me that there's 19 total in the whole circle, but I still need to figure out how much is in each part of the circle. How many students are doubled up in physics and chemistry, just like I did in college. Loved it. Okay. Then there's 17 that study chemistry. So I'm going to use that same strategy, store the information right there. And then it says 15 study both of these subjects. Okay. So both is that word that means intersection, right? And so both is right here. Now, here's where some people are like, oh yeah, that makes total sense. And some people are like, wait, can you explain that again? So listen up. If there's 19 total in physics, right? And there's 15 that overlap, then how many are just taking physics? 4. Okay, and that's because 4 and 15 add up to 19. Now, same for chemistry, right? 2 are over here. These are a lot of tryhards in here. There's only a few kids that aren't doubled up. Most of them are doubled up in physics and chemistry. That's a lot. Okay, so display this information in a Venn diagram. We pretty much did. The only thing we don't know right now is the outside. And determine the probability that a randomly selected class member studies. So whenever you hear or read in a probability problem that it says a randomly selected, it's just telling you that like you don't know anything about the situation. Everybody has an equal chance of being chosen. Okay, so how do we find this outside thing? How many students are taking neither physics nor chemistry? So in order to figure this out, you need to have this idea that you understand that the total number of people in this whole Venn diagram is 30, okay? So if I were to add up everything so far, we have 4 and 15 and 2. 4 and 15 and 2 makes 21. So there's only 21 people that we've accounted for so far. So what does that mean? That means that there are still a bunch of people who haven't been accounted for, and that's because they're the people out here. They're the people not taking chemistry or physics. They're taking something else. Maybe they're taking bio, or they're taking anatomy, or they're taking fashion tech, or something that interests them a little more than science. Okay, so you can always double check and add up 4, 15 to 9. Make sure it adds up to 30. Okay, let's start off on some of these questions. Again, if you want to try some of these questions on your own, you don't want to come along with me and do them at the same pace as me, totally fine. Pause the video, try it on your own, come back, check your answers at the end. If it turns out you did it wrong, no big deal. Just go back, rewatch it. All right, so here I'm going to do A. I'm going to think about what's the probability that somebody takes both subjects. So I'm going to draw out what this means in probability notation. Probability that someone takes physics and chemistry. That word both means intersection. So we look for the part of the question that is where they overlap, and that would be the 15 over the 30. And then writing this as a percent, I can do this in my head because this one is half, so it would be 50%. All right, question B. We have what's the probability of at least one of the subjects. So this is kind of a weird word, and it's going to pop up again. I don't know if we'll get to it because of the distance learning, but it's going to pop up again next year in pre-calc for sure. At least one means it could be one or it could be both, right? So it could be physics alone, could be physics or chemistry alone, or it could be doubled up, both chemistry and physics. So we're going to do the probability of physics or chemistry. At least one means or in this situation. So that's everything but the 9, right? It's everything inside of the circles. So it'd be 21 over 30, which I feel like I should be able to do that one in my head. Oh, man, 70%. Always trying to challenge myself to do more mental math. Definitely one of my weak points. All right, so let's do number C, letter C. All right, C, physics, but not chemistry. So only physics, not chemistry. Okay, so don't worry if you weren't able to come up with the notation for this one, but it's saying that it has to be in physics, and then it has to intersect with not chemistry, right? It has to be both physics and not chemistry. In the picture, it's a little more clear. Physics, but not chemistry. That's these 4 people out here. So it's going to be 4 out of 30. This one I don't think I can do in my head. It is 13.33%. Squish in the corner over there. All right. I'm going to get this out of the way. You guys all know it's out of 30. So question D says exactly one of the subjects. And this one is, I'm going to skip the notation on this one because it would just be a little bit complicated. So it's just either the 4 people over here taking physics or the 2 people over here taking chemistry. So it's just 6 out of 30, which is a fifth. So it should be 20%. Let's see if I got it. Yeah, 20%. All right, E, chemistry, but not physics, right? So this is the opposite of what we did in question C. It's what's the probability of chemistry, but also it has to be not physics. And so that would be the 2 out of 30, which is 1 out of 15. I don't know, 1 out of 15. Okay, so 6.67%. Don't mess up on your rounding. Okay. We got F, neither subject. So that means those people who are outside of the circles, people who are not in chemistry and not in physics. So this one's kind of a weird one, but maybe you remember it from the examples we did above, where it's the probability of not chemistry, and also they can't be in physics. So the inner overlap of not chemistry and not physics would be 9 out of 30. I should be able to do this. So that's 20. No. Is that 20%? 9 divided by 30. 30%. Oh, duh. 30. Oh, I was thinking. Okay. See, you gotta work on it. You gotta keep your brain sharp. This is what happens. Gotta keep trying, get better and better at mental math. Okay, last one. This is one where we're going to bring in conditional probability. It's where we get to cut people out of our life, right? Be like, I don't care about you. The only thing I care about right now is what? What is it? Let's read the question. So it's probability of chemistry given, right? That's that conditional probability that they study physics. So we get to say goodbye, everyone, but physics. Physics is all I care about. And we can look up here. We know the total for physics is 19. And then within that physics, where's the chemistry? That's the people in the middle. So 15 out of 19. Let's do it. 15 divided by 19 is 78.95%. All right. Now think about it. How hard would these questions be if you didn't have this diagram, right? If all you had was this information written down and you just had to figure out the probabilities by like thinking really hard and like going through logic in your head, it'd be more difficult. So it's really great that Venn diagrams exist because they help us visualize logic problems and then attack them using a strategy that is a lot easier than just trying to like rack your brain and figure it out without the visual. Okay, we'll do one more IB style or application problem here. And this one's really important because you're going to see it information given to you in a way which we haven't seen before. And there's a lot of IB questions that are like this. So it's really, really important that we've seen them before. This is our final question. It is talking about event A and B. Okay, so not real life, just IB question, such that the probability of A is 0.3. Now, it says 0.3, but probability can be given as a decimal, right? So 0.3 is actually 30%. So keep that in mind. So you can do this one of two ways. You can write it as a percent, right? You could say, okay, 30, and then that means my total is 100 because percent means out of 100, right? Or you can keep it as a decimal and you can say, okay, 0.3. Well, then if I'm writing it as a decimal, then my 100% would be a total of 1. So I'm going to keep it like this just so we can get some practice with using our mind with the decimals because it can be kind of different. We haven't seen it like this before. The probability of B is 0.6. Oops, and I already made a mistake. So remember, if it says the probability of A, that means everything that is in A. If it says the probability of B, it means everything that's in B. So we don't want to put it inside of the circle because that means it's like doesn't include the overlap. Oops, and this one's formatted a little weird, but it says probability of A union B is 0.7. So that means everything in this whole area here is 0.7. So technically, these two, right, they should add up to 0.7, but they actually add up to 0.9. We have 0.2 too much. Why is that? Because that's the overlap, right? When we double count the overlap, that's when we have too much. So whenever something adds up to too much, we know it's because we double counted the overlap. So what that means is we know 0.9 minus 0.7, right? That's this information that I'm getting from over here is equal to 0.2. So our 0.2 goes in the middle. Now we can start filling in the rest of the information. So that means this would be 0.1 because 0.1 and 0.2 adds up to 0.3. And that means that this would be 0.4 because 0.2 and 0.4 add up to 0.6. Cool. Now we have to do that thing that we did before where we knew the total was 30, but we didn't add up to 30. And so that was the part that's outside of the circles. So what do we have? We have 0.1, we have 0.2, we have 0.4. What does that add up to? That adds up to 0.7. Duh, we knew that. So how much are we missing to get to 1? So we have to do 1 minus 0.7, and that's going to be 0.3. Yay, we did it. We filled in the Venn diagram. We just need to now answer the questions. So we're not done yet. We got to answer all the questions that R in the IB style. We already did most of the work though. So A is write down the value of R. R was the middle, right? I think I covered it up. Yep. So R equals 0.2. And if the IB gives you the numbers as a decimal, you can just give your answers as a decimal. B, write down the value of T. That would be 0.3. So T equals 0.3. C, write down the value of Q and S. Q we found was 0.1. S we found was 0.4. Write down the probability of B prime. Okay, so it's everything that's not in B. So let's do it. B, everything that's not in B is all of this stuff right here. Maybe you don't need to highlight in order to find the answer, but I do. So the probability of B prime is everything that's not in B. So I'm going to add the 1 and the 0.3, and that is 0.4. Now, remember the other way to do this is that I know B is 0.6. So everything that's not B is 1 minus 0.6, right? So it would just be 0.4. So instead of having to add, I could just subtract from 1. Cool. And then E is a tricky one. Probability of A given B prime. Oh, isn't that nice? We already found B prime. You're going to see this with a lot of IB questions where they have you find something and then they have you use it in the next part of the question. So we already know that our denominator is going to be 0.4. Now let's cut everything that's not B prime out of our life. I don't care about you, and I don't care about you. B prime is all I care about. So anything inside of B, goodbye. So now, A, out of what's left, what's in A? 0.1. So that would be 0.1 out of 0.4, which is the same as 1/4, which is 25%. Okay, so just like last week, I want you to do this exit question. Give it a shot. It's given in percents. So you get to practice going out of a total of 100. I'm going to post these notes for you with the answer to the exit question, but it'll kind of force you to, actually do it on your own and then go back and check your answer. Hopefully, that's my hope. Okay, so I had a lot of fun. I really like Venn diagrams. I hope you guys are having fun too. Do the worksheet, do the formative, do the summative. It's all good. Feel free to communicate with me. Please email me. It's making my days so much easier when I get to hear from you and I get to answer questions. It's my favorite part. Being a teacher is getting to answer questions. So, this is fun, but really it's you guys that make my job excellent. So keep making it excellent. Keep checking in. And I hope you have a great week.